Hello everyone. I will be solving today's LeetCode problem 712, that is minimum ASCII delete sum for two strings. First have a look at the question, then we will discuss the answer. First of all, let us understand the question. Let's say we are given two strings, delete and leet. So you can see there can be many subsequences of these strings like EET or LEE or LET or even say LE. So let's say for example we take EET as a common subsequence of these two. So deleting EET from both the strings we get, here we get DLE, and from this string we get L. So the sum of DLE plus L's ASCII values this sum should be minimum. For this sum to be minimum, we have to find the longest common subsequence so that we'll get the minimum sum. After looking at the question, my first instinct was to find the common elements of both the strings and then delete the common element from both the strings, so the resultant elements are the one that we have to delete. Now add the ASCII values of all those elements and we get the result. In this solution I have done the same thing, but sure enough this solution got me the test cases, but while submission this was not running. Now let us understand what were the flaws in my approach. The first is presence counted but not usage count, which means I have checked whether the character is present in string or not, but I haven't counted how many times it is present. The second is order of characters is ignored, which means whatever the order of character may be, the com one has alphabetical wise only. And the third is only one occurrence is deleted. That is, for making the longest common subsequence, we can delete multiple occurrences of a character, but I have just deleted a single occurrence. And the last is old lengths were used. That is, while summing the ASCII values of deleting elements, I was using the old length of the string. Now we will look at the actual solution approach. So in actual solutions, we have to calculate the ASCII values sum of two strings total, and then we will just take a DP approach in which we will calculate the ASCII sum of just the longest common subsequence, which means here you can see that we have two words, SCA and EAT. So first we will take out the total sum. The total sum comes to be 627. Then later in DP approach we will count the maximum longest subsequence ASCII sum, and the maximum longest subsequence ASCII sums comes out to be 198, and then we just delete the total minus 2 into sum of longest common subsequence ASCII sum, and it is subtracted twice because it has occurred in both the strings. Looking at DP in detail, we see that instead of checking longest common subsequence of SCA and EAT directly, we are breaking it into sub-problems. Like first we will check longest common subsequence of S and E, then we will check S and EA, and similarly here you can see this is the base case. In base case we consider that both the strings are empty. Now in S and E there is no longest common subsequence, so the ASCII sum is 0. In S and EA it is also 0. In S and EAT it is 0. In SE and E there E is common, so we are adding ASCII sum of E. In SE and EA only E is common, so here is also 101. And when we come to here, this part, we can see that in SEA and EA, EA is common. If EA is common, so the ASCII sum of E and A will be 198. And like this, when we come to the last block, that is if the size of string 1 is M and size of string 2 is N, then at the cell MN, we will get the maximum sum. Now, deleting the maximum sum from the total, we get the minimum sum that is to be deleted to make the two strings equal. You can look at the final solution on the screen.